Hello everyone, welcome to my channel CISC Topper Classes. Today we are going to discuss chapter 9 Arithmetic and Geometric Progression exercise 9.5 question number 1 to 6 of ICSE M.L.aggarwal Mathematics. So let us start solving this exercise. Now let us solve question number 1 of exercise 9.5. We have to find the sum of this series as it is given only this is a GP. So formula for the sum of a GP is a1 minus r की power n divided by 1 minus r, or we can write it as a, or this will be a rn minus 1 upon r minus 1 if r is less than 1, if r is greater than 1 here. So these two formulas we have to use for the sum. Simply if we want to find the 20 terms of the series sum, so here it is given r, we can simply write this is 3. Now 20 terms, n is equal to from there 20. Sum of first term is also given, that is 2. The sum will become, as r is greater than 1, so we will apply this one formula here. This is 2. R ki power n will become 3 ki power 20 minus 1 divided by 3 minus 1. So this will be 2, 3 ki power 20 minus 1 divided by 2. Cancelling this, we will get 3 ki power 20 minus 1 as the final answer in this question. And this is only the sum of the question number first question. Now let us solve question number first, second part. Here number of terms is 10 and the first term in this GP given is 1. R will be root 3. So for Sn we have to find, as this is less than 1, we can simply use the formula a1 minus r ki power n divided by 1 minus r. So a will become 1, 1 minus root 3 ki power 10 divided by 1 minus root 3. So simply this will become, on solving, 1 minus 3 ki power 5 divided by 1 minus root 3, and 1 minus 3 ki power 5 will become 243 divided by 1 minus root 3, and this will become 1 minus 242 divided by 1 minus root 3. As there is an irrational number in the denominator, so we can simply rationalize this part here. 242 divided by 1 minus root 3 multiplying by 1 plus root 3 and dividing by 1 plus root 3. So here this part will become minus 242 1 plus root 3 divided by 1 minus 3 equal to minus 242 1 plus root 3 divided by minus 2. Minus will be cancelled out, 121. So this will become 121 1 plus root 3 as the final answer in this question. And this is the solution of question number first, second part. Now let us solve question number first, third part. 6 terms of the GP, we have to find the sum. So as the first term is 1, r will become minus 2 by 3, and the number of terms is 6. So from there we can write the sum, as this is less than 1. So we can write sum as a 1 minus r ki power n divided by 1 minus r, putting the value 1, 1 minus 2 by 3 whole power 6 divided by 1 minus 2 by 3. So simply 1 uh, minus 2 by 3 will become 2 by 3 ke 6 power, because minus will be cancelled out, only simply divided by 1 plus 2 by 3. Solving this part, we will get 1 minus. So here this will become 1 minus 64 upon 729 divided by 5 by 3. Here taking LCM here also, that will become 729 minus 64 divided by 729 multiplied by 3 by 5. So this will become 9 minus 4, 5 only, and 72 minus 6 will become as 66. So 665 upon 729 multiplied by 3 5. Cancelling this part, we will get 3 here, and this side will be again 3. Again cancelling this part, we will get 2, 4, 3. Now we can cancel here also. So from here the sum of this GP is 133 divided by 243 as the final answer in this question, and this is the solution of question number first, third part. Now let us solve question number first, fourth part. We have to find the sum of 5 terms firstly. Number of terms is 5. First term is 1 of the GP and common ratio is 2 by 3. So simply Sn, sum of the terms will become a 1 minus r ki power n divided by 1 minus r equal to 1 minus 2 by 3 ki whole power 5 divided by 1 minus 2 by 3. So that will become 1 minus on solving 32 divided by 243 upon 1 by 3. So 243 minus 32 divided by 243 multiplied by 3 here. So that will become 243 minus 32, 24 minus 21 divided by 243 multiplied by 3. This will be cancelled out by 81. So we will get the final answer for sum of 5 terms of the given GP is 211 divided by 81. So this is the final answer of the first part which is asked. Now the sum of n terms will become a 1 minus r की power n divided by 1 minus r equal to 1 minus 2 by 3 की whole power n divided by 1 minus 2 by 3, that will become 1 minus 2 by 3 की power n divided by 3 minus 2 by 3 will become 1 by 3 only. So 1 minus 2 by 3 की power n multiplied by 3. So this is the final solution, means the sum of n terms of the given GP, and this is the final answer of question number first, fourth part. Let us solve question number 2. We have to find the sum of the series here, where first term is 81, common ratio is minus 1 by 3, and the last term is minus 1 by 27. From the last term, we can find the number of terms here. So that will become minus 1 by 27. So it will become minus 1 by 27 equal to 81 multiplied by minus 1 by 3 and minus 1. So minus 1 by 27 into 81 equal to minus 1 by 3 and minus 1 as minus 1 by 3 की power 3 into 3 की power 4 equal to minus 1 by 3 and minus 1. So that will become 1 minus 1 upon 7 uh, equal to minus 1 upon 3 n minus 1, n minus 1 equal to 7, n is equal to 8. So number of terms is 8 here. Now sum of terms, if you want to find a, 1 minus rn upon 1 minus r equal to 81, 1 minus 1 by 3 n upon 1 minus n की जगह 8 we can write here. So 1 minus 1 by 3 equal to 81. Here that will become 6561 minus 1 upon 6561 multiplied by 2 by 3 here. So simply 81 multiplied by 6560 upon 6561 into 3 by 2. So simply we can cancel out here 3 280. So that is 6560 only. So 3 280 it is cancelling here. Now if we want to cancel again, so again if we cancel this part, that will become, sorry, this is here minus 1 by 3. So we are going to add it and this will be 4 here. So again we can cancel out by 2 and then again cancelling by, it will become 1690 1640, sorry, 1640, and cancelling this part we can write clearly here 81 multiplied by 1640 multiplied by 3 upon 6561. Cancelling this part we will get 2 1 again here, that is 2 1 26 here 8, so 7. Again we can cancel out here, that will be cancelled by 9, then again 2 38 here, so 4, and again to 27, so 3. Again cancelling this part we are going to get 18 here. Now 63 will be 27. So we are getting 1640 upon 27 as the final answer in this question. Means the sum of the 8 terms of the given GP is 1640 upon 27 is the final solution of question number 2 here. Let us solve question number 3. The nth term of a GP is 128, we know, and the sum of its n term is 255 given to us. So nth term means, if we write the nth term here, an, that is arn minus 1. So that is given to us as 128, means the last term is 128. So that is n minus 1. And if we write here the sum is given to us of n terms as 255, means here if we write the sum, that will become a 1 minus r ki power n upon 1 minus r equal to 255. Putting the values here, a r n minus 1 we know, so that will become here a minus a r n minus 1 multiplied by r divided by 1 minus r equal to 255. We can put the value here in place of ar n minus 1 as a minus 128 r upon 1 minus r equal to 255. So multiplying this side, same thing, 1 minus 28 r equal to 255 minus 255 r. We can solve it like this, a minus we can write a minus 255 equal to minus 255 r plus 128 r. So a minus 255 equal to minus 255 plus 128, we will subtract here, so that will become 7 again. 24 minus 12 will become 12 only, so minus 127 r. And if its common ratio is given to us, that is 2, this is given in the question, we can simply write the value of a as a equal to minus 127 into 2. So on solving, that will become 254 minus 254 plus 255 will become a is equal to 1, means the first term in this given GP is 2 only, and this is the only the thing which we have to find in this question, and this is the final solution of question number 3. Solve question number 4, first part. How many terms of the GP are needed to give the sum 120? It is asked here. So simply sum of terms we have to find. How many terms means Sn we have to find, which is a 1, and if we write the common ratio here, that will become 3. First term is 3. So simply r ki power n minus 1 upon r minus 1. Sn here is Sn only, putting the value 3. R ki power n will become 3 ki power n minus 1 upon 3 minus 1. Number of terms, so we have to find. Sn is also given 120. How many terms now are needed? So 3, 3n minus 1 upon 2, that will become 120 into 2 divided by 3 equal to 3n minus 1. Cancelling this part, we will get 40. 40 into 2 will become 80 plus 1 equal to 3 ki power n, which is 81. Now 3 ki power 4 is 81. So on comparing, we will get number of terms are 4. 4 are the number of terms which are needed to give the sum 120 in this given GP, and this is only the final answer of question number 4 first part. Now let us solve question number 4 second part. How many terms of the GP must be taken to have their sum equal to 341? So again same formula if we apply. First term is 1, r is 4, so we can write a r ki power n minus 1 upon r minus 1 to find this. Sum is 341. First term is 1. R is 4 ki power n we have to find in this question. 4 minus 1. So that will become 341 equal to 4n minus 1 upon 3. So that 341 into 3 equal to 4n minus 1 will become 12, 10 here equal to 4n minus 1. 4n will become 1024 here. So this will become here 4 ki power n as 4 ki power 5. Comparing this, number of terms is 5, whose sum is equal to 341. Means number of terms is 5 in this question. And this is the solution of question number 4, second part. Now let us solve question number 5. We have to find how many terms of the series will make the sum 55 by 72. That will become Sn a r ki power n minus 1 upon r minus 1, where first term is 2 by 9. If we write common ratio, that is minus 3 by 2 if we write. And now number of terms you have to find here. So 55 by 72 equal to 2 by 9 minus 3 by 2 n minus 1 upon minus 3 by 2 minus 1. 55 by 72 equal to 2 by 9 into 2 upon minus 5, and again minus 3 by 2 n minus 1. This will become 55 by 72 into 9 by 2 into minus 5 by 2 equal to minus 3 by 2 n minus 1. So solving this part, this is cancelled out by 8 and we will get, on multiplying 55 into 5, minus 275 we are getting, and divided by 32. So this part on solving, minus 3 by 2 की power n minus 1, this will become minus 275 upon 32 plus 1 equal to minus 3 by 2 की whole power n, minus 275 plus 32 divided by 32 equal to minus 3 by 2 की power n. So here we will get, on solving, 5 minus 2 will become 3 only, 27 minus will become minus 243 upon 32 equal to minus 3 by 2 की power n. So if we write this part, we are simply getting as minus 3 by 2 की power 5 here, as minus 3 by 2 की power n. On comparing, n is equal to 5 means the number of terms which are needed to make the sum 55 by 72 of this given geometric expression is 5. So this is the final answer of question number 5, and this is the given solution of question number 5. Now let us solve question number 6. The second and fifth term of geometric series are minus 1 by 2 and 1 by 16. So simply a2 we can write minus 1 by 2 equal to ar, and 1 by 16 as ar4. So this is first and second, dividing 2 by 1. Dividing 2 by 1 we will get 1 by 16 into minus 2 equal to, this will be cancelled out, and r3, and this will be cancelled out by 8, minus 1 by 8 equal to r3. If we write now minus 1 by 2 की power 3 equal to r, we can write on comparing, r is equal to minus 1 by 2 here. Now from there, the first term we can write on putting value of 1. We are getting divided by r. So minus 1 by 2 divided by r will be 1 by r only. Putting value of r here, sorry, this will become as minus 1 by 2 equal to ar. Putting the value minus 1 by 2 equal to a into minus 1 by 2, minus minus will be cancelled out, and this will be 1. Means first term of this given GP is 1. From there we have to find the sum of the series of 8 terms. That will become a 1 minus r की power n divided by 1 minus r equal to, first term is 1, 1 minus minus 1 by 2 की power 8 divided by 1 minus minus 1 by 2 here. So simply solving 1 minus here, if we write 1 by 2 की power 8 as 1 by 16 into 16. So solving this, this will become 256 upon 1 plus 1 by 2 equal to 255 upon 256 into 2 by 3. So solving this part, it will be cancelled out by 85 here. This will be cancelled out by 128. So the final answer means the sum of 8 terms of the given GP here is 85 divided by 128 is the final answer, sum of the series, and this is the final solution of question number 6 here. Firstly, we have finded the value of common ratio and first term, and then we have finded the value of sum of 8 terms of the series here.
Thank you for watching my video. If you like this video, don't forget to like, share and subscribe my channel for more such videos.